All right, class. Last part two of sample 10A sample exercise. This one's 10.7. 10.7 is on page, there we go, 414. About halfway through, right underneath to give it some thought. This is sample exercise 10.7. It says, what's the density of carbon tetrachloride vapor at 714 and 125 degrees Celsius? So we know that we're going to use density equals, density is going to be equal to pressure times molar mass divided by the R value and temperature. All right, so we got a couple of things we need to do here first to prep for this. We know that we're going to have, so the pressure is given to us in torr. That's an easy one, 714 torr. Lots of people, even the book, would want you to change that to atmospheres. So you could use the R value of if you have your R value in atmospheres, it's 0.0821, that's liters times atmospheres over mole Kelvin. Why not just use, instead of go through the math, why not just use the R in torr, which is 62.4, and that's torr times liters over mole Kelvin. Instead of going through the math of the conversion, just know what the other R value is. So that's the R value we're going to use here. 62.4, and that is torr times liters over mole Kelvin, like that. And then we're going to have to change. Notice that our temperature is given to us in 125 degrees Celsius, so we have to add 273 to that to give us our Kelvin temperature, so we can plug that in up top. That looks like it's going to be a 398 when we add those two together, like that. The other part to this is the molar mass. Well, molar mass equals the number of moles per mass, the number of grams per mole of carbon tetrachloride. Carbon tetrachloride, CCl4. That would be my 12 plus, and then 35.5 times 4 times 4 here is going to give us 142 plus 12 is 154 grams per mole as my value, 154 grams per mole. So 4 times 35.5, 2 times 35.5 is easy enough, that's 71, and then times 2 would give us 142. And then add another 12 to that, so that gives us 154. Once I go through all of this, I should have a value very close to, now make sure we cancel off, this is grams over moles on the top. So moles cancels with moles on the bottom here. Kelvin cancels with Kelvin. Torr cancels with torr, which means I'm left with grams per liter. So it's 4.43 grams per liter as my density. No, it's not grams per milliliter, because density of a gas is much less, 1,000 times less than density of a solid or a liquid. So there's my answer there. I'd be more than happy to answer the questions that you have for this on Monday. So ask me about that on Monday. Let's go right into 10.9, relating the volume of a gas to the amount of another substance in a reaction. Safety airbags. Okay, let's make this quick here. Safety airbags are inflated by nitrogen gas generated by the rapid decomposition of sodium azide, which is NaN3. So, if an airbag has a volume, the first thing I'm going to do is use my PV equals nRT. We're going to use that the most this chapter, because this is the ideal gas law and can be used in just about any situation. So I'm just going to start to plug in. When I go from, I'm looking at the airbag, which means that my gas that fills the nitrogen gas, I have all the information for nitrogen gas, so I'm going to go from nitrogen gas and find the number of moles, and then convert that to the number of moles of NaN3, and then I'll convert that to grams to answer the question. Okay, it says how many grams of NaN3 must be decomposed. So that is my end result, will be the grams of NaN3. So let's see if we can do that. I need to find moles first of my N2. So moles equals, we did this before, we divide both sides by RT. That means N equals PV divided by RT. Let's plug in all the information we have. I have 1.15 atmospheres. I have, for volume, I have 36 liters. So that's already in liters. I don't have to convert anything. So after 36 liters, I have my number of 26 for temperature, 26 degrees Celsius plus 273 equals 299 Kelvin. My R value when I have atmospheres is 0.0821. Let me see if I can clean that up a little bit. 0.0821. Okay? So this here will give us the number of moles, and I end up with about 1.7 moles of N2. Now, 1.7 moles of N2, I multiply that. Now I'm going to use, you see this here? 3 moles of N2 for every 2 moles of NaN3. So I put the 2 moles of NaN3 on top, the 3 moles of N2 on the bottom. That gets me about 1.1 moles of NaN3. I need to keep going here. I'm just about finished. So I do 1.1 moles of NaN3, and now my last step then will be to, let me see if I can move this whole thing over. My last step will be to 23 is the molar mass of sodium. Nitrogen is 14 times 3 is 42. So that gives me 65 grams per mole, like that. Oops. That should be on top, like that. And it's 65 grams per 1 mole. Wow, I haven't done this kind of calculation in a while. So 1.1 times 65.5 gets me 72 grams of NaN3 that needs to decompose. Okay, excellent. So let's, good luck. Oh, ask all the questions you need to on Monday. We'll see you guys later. Have a good weekend.